Okay, so today we're going to be looking at the sine rule. It's another trigonometric rule that we're using. A little bit of information about it. What's important? It will find for us the length of sides. It could also find for us angles, but the most important thing is that this will work in any triangle whatsoever. So it's even better than SOHCAHTOA, which only worked in right angle triangles. What information do we need to be able to use this? Well, there has to be two sides and two angles involved. I use the word involved because one of those things is what we actually have to work out. So I don't mind if I have two sides and one angle and I want to work out the second angle, or I can have two angles and one side and want to work out the other side. That's fine. What's important, we've said from the diagram before that's given to you, okay, is that angles and sides must be opposite each other. So for instance, if this is an angle A, I have to know something about side little a. If this is angle B, I have to know something about the opposite side, which is side little b. And if this is angle C, then the opposite side would be little c. So remember, small letters like this, A, B, C, are representing lengths. Capital letters A, B, C are representing angles. Now this formula is given to you in the GCSE formula sheet, okay, so it's at the front of the exam. You need to know where it is, you need to be able to use it. And this is what they give you. There's three sections there, so they're literally saying, if we know what side A is, and we can divide it by sin of this angle A, it would be equal to side B divided by sine of angle B, which would also be equal to side C divided by angle sin C. Alright? We're only ever going to be using two of these three parts. You're never going to be using all three at the same time. What they don't tell you in the GCSE exam is that you can actually flip this whole formula upside down. Okay, so we could have sin A over A is equal to sin B over B, which is equal to sin C over C. Now the reason why you may want to do that we'll come on to in a second when we have a look at these two examples. But all you need to know first of all is that this formula is given to you on the formula sheet, and that you can flip it upside down and it still works absolutely fine. So let's now have a look at, got two examples here. One example where I'm wanting to calculate the length of a side, one example where I'm wanting to calculate the angle. For this, remember what I said, we're only ever going to be using two of the three parts. So I need to be able to label these sides and these angles accurately. So I'm just going to use A and B. Remember, little a, little b, because they are my sides. What I have to be able to do now is accurately label the angles. So if this is side A, directly opposite is angle A. If this is side B, directly opposite is angle B. So what I'm going to be using is just these two parts. I'm not going to be using the C because I haven't used that in any way. And my question is, what is it that I want to work out? B, okay, or X. In this case, it's the length of a side. The little letters represent the length of sides, which are the numerators, okay? And I want those to be on top. So I'm going to be using A over sin A is equal to B over sin B. Now it's important that I'm using the lengths of the sides on top, because that's what I want to work out. I don't have to, but it makes my life a whole lot easier. Now I'm going to substitute in as much information as I have. So what is A? 5. Good. Over sin A, which is 30. And that is equal to B, which is X. Yeah, we don't know what that is, that's our unknown. Sin B, which is the sin of 40. Now, all I have to do is be able to now solve this equation. We've got one unknown, and just like we always do, this means X divided by sin 40. So if I was to eliminate that divide by sin 40, how would I do that? Well, I would multiply it to both sides. So that is going to leave me now, I'm going to have 5 over sine 30 times by sine 40, and that will leave me the side X. If you're going to type it into your calculator, my advice is first of all do 5 divided by sin 30. You get an answer for that, which is 10. Then multiply that by sin 40. Again, your calculator must be set into degrees for the GCSE, so you need a little D at the top. If you type that into your calculator, you should be getting your answer of 6.43. What is it? Well, we're talking about the length of a side. The lengths were measured in centimetres. so it's 6.43 centimetres. Now you go into exam technique. Is that a reasonable answer? Well, it sounds about right. If we're looking at 5 centimetres, 6.4 centimetres doesn't sound out of place. If I get an answer of 127 centimetres, that doesn't look that good. Straightforward. Okay, example 2 now though. This time a little bit different because I have 2 sides and 1 angle and I want to work out the second angle. So again, I've got 2 angles and 2 sides involved in the question, which is what we said was important for being able to use the sine rule here. This time I want to work out an angle, okay? These are the angles, sine A, B and C. I'm going to use this type of the formula. The reason is that the angles are in the numerators. They're on top of these fractions and that's going to just make your life a lot easier. Once again, I need to be able to label. I'm going to make that angle B. Okay, so if that's angle A, directly opposite is my side little a. If this is angle B, directly opposite is side little b. Now what I can do is actually start using this formula. So I'm using sine A over A is equal to sine B over B. Substitute it in. What is sine A? Well, A is our unknown, so it becomes sin X over, what's little a?
7.
7. Well done. And that is equal to sin B. Well, what's angle B? 50. This one up here. Good. Over, what is side little b? 8. Once again, I've now set up this equation and all I actually have to do is solve it for x. Well, because we've put that x in the numerator again, all I need to do is eliminate that, divide by 7. How do I do it? Multiply both sides by 7, so I'm left with one simple sum to work out there. Once again, type in first of all sin 50, hit equals, get an answer for that. Divide it by 8. And you get a very small number, and then we need to now multiply that by 7. Okay? Problem is, what is it that I'm actually physically working out there? It's not angle x. If you look at your answer, you've got 0.67. Does that sound like an angle? No. That is what sin x is equal to.
Sin negative x.
So, just like any equation, how do I eliminate that sin? What's the opposite of sin?
Sin negative 1.
Sin negative 1, inverse sin. How do we get that? Well, remember, on most of your calculators, you will press shift and then the sin button. And then that will come up on your calculator. You need to, in brackets, type in your answer, 0.67, or you could just leave it as that. If you've got the answer in your screen, leave it in your screen, just hit shift sin equals, and to 3 significant figures, that should give you 42.1. What was it we were working out? Well, it was an angle, so it's 42.1 degrees. Again, does that sound reasonable as an answer? Yeah, it does. Looking at the triangle, it looks like an acute angle. 42 degrees sounds reasonable. Ladies and gentlemen, I give you the sine rule. Easy as that. Grade A GCSE.